Alrighty, so I'm gonna go ahead and do that first problem again, even though we just did it in the last lecture. But if I'm given f of x equals negative 2x squared plus 4x plus 6, and I'm asking you to write the equation in vertex form. And vertex form is f of x equals a times x minus h squared plus k. I need to divide all these numbers by -2. So this gives me f of x over -2 equals x squared minus 2x minus 3. And then I can do the completeness square. So this will then give me x squared minus 2x plus a blank minus a blank minus 3. The numbers that go in there is your b divided by 2 squared. So that's 2 divided by 2 is 1. 1 divided by, or 1 squared is 1. So 1 goes here. Then this trinomial will turn into a binomial squared. The number that comes here is just the b divided by 2. So -2 divided by 2 is -1. -1 minus 3 is -4. But the whole time this was equal to f of x equals to -2. So then I just take this and I multiply -2 here, here, and here. These -2s would cancel. I'm not going to distribute. So I just write it like this. And then -2 times -4 is +8. So there is your vertex form. Part B then says determine whether the parabola opens upwards or downwards. All you gotta do is pay attention to your A. If the A is positive, it opens up. If the A is negative, it opens down. So this opens downwards. Since A was less than 0, this being A. All right. Part C then says identify the vertex. Well, the whole point of the vertex form is this is your vertex, h comma k. So my vertex will be, remember, we changed the sign of the h. So instead of a -1, it becomes a +1. The k will stay the same, so it becomes 1 comma 8. Part D says identify the x-intercepts. So this is when we set it equal to 0. Easiest thing to do is take the vertex form that you've already solved for, set it equal to 0. So that's -2, x minus 1 squared plus 8 equals 0. So I'll subtract 8 first. Oh, my bad. Hold on. All right, now I'll divide by -2. Excuse me, 4, and then I'll take the square root of that. Don't forget the plus or minus. So I do get x minus 1 equals 1, and x minus 1 equals, not 1, sorry, 2, and -2, because again, this is plus or minus 2. So I'm going to set x minus 1 to each equal to one of these. I'm going to add 1 to 2, and I get x equals 3. I'm going to add 1 to this one, and I get x equals -1. So those are my x-intercepts. I'm good with you writing it like this. If you want it to write it as 3 comma 0 and -1 comma 0, that's perfectly fine with me. I wouldn't take off either way. Part E then asks identify the y-intercept. Remember, the y-intercept is just the c. So here it's just going to be y equals 6, or you could write it as 0 comma 6. F states sketch the function. So now that we have the function, graph your x-intercepts. So that's 1, 2, 3. You'll be given a graph on the test, so don't worry about it, and make your own. Y-intercept is 1, 2, 3, 4, 5, 6. I know it opens downwards. I do have the vertex, so that's 1, 2, 3, 4, 5, 6, 7, 8. There you go, right there. And then you kind of just connect all the things that you've come up with. And there you go. Part G says determine the axis symmetry. Remember, the axis of symmetry is x equals h, or h is the vertex here. So in this case, it's just x equals 1. Make sure you write the x equal. I will take off. H says determine the minimum or maximum value of the function. Well, because it's open downwards, it is a max, and the value will be the y value. So in this case, that would be 8. All right, and then I says state the domain and range. The domain is super easy. It is always going to be negative infinity to infinity. The range goes from bottom to top. So since I'm going downwards, the bottom is negative infinity, and the top would be the y max, which is 8. And it will always get a bracket. All right? That's how you do part 1 or question 1. Right? On question 2, I give you this function, f of x equals negative 4x cubed plus 16x squared plus 25x minus 100. Part 1 just states determine the end behavior of the graph of the function. Remember, we do that by just paying attention to the leading term. If it is a odd, so it's an odd exponent, and a negative, it'll open this way. Oh, right, nope, I got that backwards. Open this way. Because if it's a positive odd, it goes this. Think of an x cubed, and then we'll flip it and it goes this way. So that means that the end behavior here would be the limit as x approaches negative infinity, which is the left side of f of x, is equal to positive infinity, since the left side's going up, and then the limit as x approaches positive infinity of f of x would equal negative infinity. This means the right side, so the right side's going down. All right, part B. Right, end behavior graph. All right, find all the zeros of the functions and state their multiplicities. All right, so all we're going to do is we take this and we're going to find a zero using possible zeros. So, well, let's see. Looking at this, I actually think this might be factorable. Let's see if it's factorable. If it's not, you can always use the possible zeros and use synthetic division until you get one. But if it's factorable, it makes our life a little bit easier. So a 4-term polynomial, this is factored by grouping. And I notice that on these first 2 terms, they have a negative 4 in common and an x squared. So then I'm left with x minus 4. Over here, I see they have a 25 in common. So I am going to say plus 25, so I know it's a positive. I notice that gives me x minus 4. If these guys are the same, I factor it out as one single binomial, not a square, it's a single one. And then those go away. And then I write my binomial that I have left, which is negative 4x squared plus 25. To find the zeros, remember we just set these equal to 0. So that's x minus 4 equals 0. And negative 4x squared plus 25 equals 0. This is just simply x equals 4. I would subtract 25 first, so I get negative 4x squared equals negative 25. Oh, that's a 4. Then I would divide by negative 4. And then I get x squared equals 25 over 4, since two negatives make a positive. Then I would take the square root. Don't forget the plus or minus. So this ends up being plus or minus. And then you can split this up. The square root of 25 is just 5, and the square root of 4 is 2. So I actually get plus or minus 2. So as your end result, I can just say x equals 4, comma, plus or minus 5/2. I don't care if it's in order. I don't care if you write plus and minus or positive 5/2 and negative 5/2. I'm good here. All right. And then all of the multiplicities here would just be 1. So you could say that. You could say all multiplicities of 1. So you don't have to say 4 has a multiplicity of 1, 5/2 is a multiplicity of 1, negative 5/2 has a multiplicity of 1, and wasting all that other time. All right, C says, so part B said find all the zeros of the function and state their multiplicity. C says determine the x-intercepts. This is a trick question. X-intercepts and zeros are the same thing. So your x-intercepts are 4, comma 0 and 5/2, comma 0 and negative 5/2, comma 0. You could write it as x equals 4, comma plus or minus 5/2. I wouldn't count off for that either. D does ask what the y-intercept, but remember it's always going to be that last term, which in this case is just negative 100. So y equals negative 100. Or again, you could write it as 0, comma negative 100. All right. Part E then asks, is the function even, odd, or neither? All right, so for a function to be even, all the exponents are even. If the function is odd, all the exponents are odd. If it's neither, it has some of each. So since I have an odd and an even, right away, I already know that it's going to be neither. And then it just simply asks us to graph it. So here's the graph. So I'm going to graph what I know. I know my x-intercepts. So 1, 2, 3, 4. I got one at 2.5 because that's what 5.2 is. So I got one here and here. My end behavior I know is here and here. And I know all the multiplicities are 1, so that tells me all the multiplicities are odd. So that tells me that it goes through all of these. We didn't really get into the extremas too much. I'm not going to be looking for making sure you get to the max or the min. I know that the y-intercept is going to be negative 100. So that's going to be like way down here, right? We'll say that's negative 100. And then it's about all that I know. So I'm just going to kind of connect my stuff, make sure I go way down there, shoot up, and then eventually come back up and then finish like that. So I'm looking for this when I look for a sketch. All right. And that's it for number 2. Number 3, I give you the function f of x equals 2x cubed minus 5x squared minus 6x plus 2. And all I want you to do is determine whether the intermediate volume theorem guarantees that the function has a 0 on the given interval. So part A, the interval is -2, comma -1. So remember, all you got to do is plug in -2 into the function, see if it's positive or negative. So this is 2, -2 cubed minus 5 times -2 squared minus 6 times -2 plus 2. So do some little work here. That's 2 times -8 minus 5 times 4 plus 12 plus 2, -16 minus 20. That's going to be plus 14. That's going to be -16, -20 is -36. Actually, let's make this a little bit easier. -20 plus 4 is -6. That's going to be -22. Okay, so that's less than 0. So as long as -1 is greater than 0, then it'd be a yes. If it's not, then it's a no. So this is just going to be 2 times -1 cubed minus 5 times -1 squared minus 6 times -1 plus 2. So that would give me 2 times -1 minus 5 times 1 plus 6 plus 2. That gives me -2 minus 5 plus 8. That right there, -5 plus 8 is 3. -2 plus 3 gives me a +1. All right, so that means it's greater than 0. So the answer to this one is yes. Now, you might go, well, there's a lot of parts here. It's going to take me forever. Not so much, because the next one's -1 and 0. You already know that -1 was equal to 1, which is greater than 0. So all you got to do is plug in 0 and see what it equals. But we know if you plug a 0 in there, that's just going to be 2, which is also greater than 0. So the answer to this one is no. So then we go in part C, and the interval this time is 0 to 1. So therefore I do f of 0, which we just did, which is equal to 2 is greater than 0. So as long as f of 1 is less than 0, it'll work. But let's see. If I plug in 1, I just get 2 minus 5 minus 6 plus 2, which is -3 minus 6 plus 2, which is -9 plus 2, which is -7, which is less than 0. So that is a yes. Part D then just says 1 to 2. Again, you already did f of 1. That was -7, which is less than 0. So as long as 2 is greater than 0, we should be okay. Let's see. So 2 cubed minus 5 times 2 squared minus 6 times 2 plus 2. That gives you 2 times 8 minus 5 times 4 minus 12 plus 2, which is 16 minus 20 minus 12 plus 2. That will give us -4 minus 12 plus 2. That would give me -16 plus 2. That would give me -14, which is less than 0, which does not work. They're both less than 0. I need one to be greater than 0 and the other one to be -0. And that's all you would have to do on that. On the fourth question here, I gave you this function. 2x to the 5th minus 7x to the 4th plus 9x cubed minus 18x squared plus 4x plus 40. So that's the 5th, 7x 4th. Make sure I wrote it down right. All right, so this long thing here. Question 1 says, how many zeros does f of x have, including multiplicities? So the zeros that it has is whatever the highest exponent is. So in this case, 5. And that's it. Part B says, list the possible rational zeros of f of x. So this is p divided by q. So that's the factors of my last term. So that's 40. If you want to do a t-chart, that's what my pre-calc kids have been doing. You can do 1 and 40, 2 and 20, 4 and 10, 5 and 8, right? Yep. Okay. Whew. 6, 7. Oh, yep. So there it is. So that's going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 8, plus or minus 10, plus or minus 20, and plus or minus 40, all divided by the factors of 2, which is plus or minus 1, and plus or minus 2. So when we do this, we divide all those by 1, which is super easy. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 8, plus or minus 10, plus or minus 20, plus or minus 40. Then we divide them by 2. 1 divided by 2 is plus or minus 1/2. 2 divided by 2 is 1, which you already wrote down. 4 divided by 2 is 2, which you already wrote down. 5 divided by 2, that's plus or minus 5/2. 8 divided by 2, which is 4, which you already wrote down. 10 divided by 2 is 5, which you already wrote down. 20 divided by 2 is 10, which you already wrote down. And 40 divided by 2 is 20, which you already wrote down. You do not have to repeat. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20 possible zeros. And that's what you do there. You just list the possible ones. C then states find all rational zeros. All right, so those are the ones that are one of these. Remember, we can have where we end up using the quadratic formula and get some radicals involved. You can have some complex zeros, but we're just going to find some here. Yeah, so you just start with 1. I just start here and I go that way. So I'm going to go with 1. and then you just kind of do the work. So this is going to be 2 for my x to the 5th. X to the 4th is -7. X cubed is 9. X squared is -18. My x is 4. My constant's 40. Watch out. Make sure you have a placeholder for every term. All right, so let's get it going. So 1 times 2 is 2. -7 plus 2 is -5. 1 times -5 is -5. 4 plus -5 is 4. 1 times 4 is 4. -18 plus 4 is -14. 1 times -14 is -14. That's -10. That's -10. And then that gives you not 0. So let's try a different one. So let's try -1. So that'd be -2, -9, 9, 18, -18, -36, 36. That gives me 40, -40. Oh, look at that. That gives me 0. So there, I found one. All right, so that gives me the x to the 4th, x third, x squared, x, and a constant. I still don't know how to factor this out, so I will do it again. Remember, I don't have to use any numbers that I already used. So I'm going to go into 2. Remember, use the new numbers to make your life a little bit simpler. So that's going to be 4, -5, -10, 8, 16, -20. Oh, look at there, -40, and then 0. Gotta love it when it works out. Now we're at x cubed, x squared, x, and a constant. What's this button do? Nope. Kind of running out of room here. So I'm going to try -2, see if that works. All right, so that's -4, -9, 18, 26, and then none of that works. So let's try a different number. Let's try +4. So that gives me 8, 3, 12, 20. That gives me 80, so that's not going to work either. Let's try -4 then. That gives me -8, -13. That's going to be negative. So that's going to be +40, 52, which is 60. That's not going to work either. All right, so let's try +5. That's going to be 10, 5, 25. That's not going to work. So let's try -5. That's going to be -10, -15. Oh, 15. That's going to be 50. It's going to be a bigger number. Yeah. That's not going to be this one either. I see that I'm getting a lot of bigger numbers the further I go. I'm actually going to skip. I've already gotten to this point, but I'm going to go to the halves. Maybe it's a half. All right, so that gives me 1. That gives me -4. That gives me -2. That gives me 6. That would give me 3. No. Maybe -1/2. All right, this will give me -1. This will give me -6. This will give me +3. That'd give me 11. No. Maybe 5/2. That'd be 5, 0, 0, 8. 2 divided by 8 is 4. 4 times 5 is 20. There we go. There's a winner, winner. Whew. All right, so then I'm left with 2x squared, because now it's a quadratic, plus 8. I would set that equal to 0. But then I see that if I do this, 2x squared equals -8, divided by 2, x squared equals -4. Then I take the square root, but then I can't. So on part C, when it says rational zeros, it doesn't want complex answers. So your answer for part C would just be x equals -1, 2, and 5/2. But then when you get to part D, now I want you to find all the zeros. So now you can say, all right, well, this is plus or minus 2i. So I get plus or minus 2i, -1, 2, and 5/2. All right, 1 second. So that would be the conclusion of D. They're just going to want or I'm going to want any complex number, any of the where you have to use the quadratic formula, where it doesn't look so nice, where you might have a square root involved. But that's what I'm looking for there. All right. So then in the next one, I give you g of x equals -3x to the 7th plus 4x to the 6th minus 2x squared plus 5x minus 4. And I want you to determine the number of possible positives and negative real zeros in the function. So possible positive zeros. I'm just going to count how many times the sign changes. So there's 1, there's 2, there's 3, there's 4. So there's 4 possible ones, but then I have to decrease by 2. So it's going to be 4, 2, or 0. All right. Define the negatives. Possible zeros. Wrote that backwards. That's right. I'm going to basically figure out what is g of -x and do the same thing. If you recall, we saw a trick. If it's an odd, I change the sign. So that's going to be positive 3x to the 7th. If it's even, it'll stay the same. So that's going to remain 4x to the 6th. Even stays the same. Odd changes signs. Constant stays the same as well. So positive, 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 negative. There's 1, negative, 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 negative. So therefore, there's only 1 possible -0, and I can't subtract by 2 because I get into the negatives. So that's all I'm looking for on that one. The next one asks you to identify all the asymptotes. So that's the vertical, the horizontal, the slants, or any non-linears. And we're not graphing, we're just looking for asymptotes. So this is going to be m of x equals 2x cubed minus x squared minus 6x plus 7, all divided by x squared minus 3. All right, horizontal asymptote to me is always the easiest because I can just look at the highest exponents. Remember, when the denominator is smaller than the numerator, there is none. So therefore, there is a slant asymptote or a nonlinear asymptote. The way we do this is, in this situation, we'll have to do long division since this is a nonlinear function that we're dividing by. Again, make sure you have a place value for everything. So if you had a missing term, just put a 0. All right, and then remember the 4 steps. Step 1, first term divided by first term. So that's going to be 2x cubed divided by x squared, which is just 2x. Line it up with your like terms. All right, that's step one. Step two, multiply your result from step one to your thing that you're dividing by. So 2x times x squared is 2x cubed. 2x times -3 is -6x. Notice I'm lining it up with its like terms. I'm not going to go over here and put it right here. Step three, I then change the sign. So this positive becomes a negative, this negative becomes a positive. I then do this, that goes away. I'm left with -x squared. That actually goes away. And then I'm going to drop down to +7 as well. All right. And then repeat the process. First term divided by first term. So -x squared divided by x squared is just -1. So that gives me -1 again. I'm lining it up with its like term. Step two, take that result, multiply it back out. -1 times x squared is -x squared. -1 times -3 is +3. Step three was to then change the sign. So this becomes a positive. This becomes a negative. And then step four, just combine like terms. This goes away. 7 minus 3 is 4. X squared cannot go into 4. So this right here is called the remainder. But when I'm looking for slant asymptotes or nonlinear asymptotes, I could care less about the remainder. This is my result. So for the slant asymptote, I'll write it as y equals 2x minus 1. Then we look for vertical asymptotes, which we would try to factor this. Knowing that x squared minus 3 can't be factored, I'm not even going to try to use synthetic division to factor this up because I know this can't go any further. So that means all I'm going to do is set the denominator equal to 0, and I'm going to solve it. So I get x squared equals 3, and then I take the square root. Don't forget to put plus or minus. So you have two vertical asymptotes at the square root of 3 and negative square root of 3. But again, I'm not asking you to graph it. So those would be your answers. There's no horizontal asymptote. The slant asymptote is 2x minus 1. The vertical asymptote is x equals plus or minus square root of 3. Don't forget your x value or x equals or y equals or whatever the situation is. And I'm also okay with you saying HASAVA rather than spell it all out. All right. So let's do another one. So this was, let's do a different color. Let's go. Okay, so that would be n of x equals -4x squared plus 5 divided by 3x squared minus 14x minus 5. When the highest exponent on the numerator and the denominator are the same, my horizontal asymptote will just be y equals the two coefficients being divided together. So that's just going to be -4/3. Simplify if you can. If you can't, you can leave it like that. So therefore, there is no slant asymptote, so I can go straight into the vertical asymptote. But we do need to make sure we can if it can be factored. However, I can tell you on the numerator, -4x squared plus 5 can't be factored at all, but we still need to factor the denominator so that we can figure out what our vertical asymptotes are. So remember, this is your A, B, and C. So my A times C is 3 times -5, which is -15. My B is -14. So if you paused it and try to figure it out on your own. All right, and hopefully you came up with 1 and -15. Those two numbers multiply -15, but add to -14. So that will then give me x plus 1, x minus 15. And then we take the A and we have to divide it. So we're going to divide both by 3. If I can't simplify it, it just goes to the front. So this is 3x plus 1. 15 divided by 3 is actually 5. So that's x minus 5. And as you can see, it can't go into any of these at all. So I just take these and I set them equal to 0. So this gives me x equals -1, which is then -1/3, and this is just x equals 5. So you have two vertical asymptotes and one horizontal asymptote. All right, and on the last page, I actually do want you to graph it. So let's take one. Where we at? There we go. So if I ask you to graph Q of X equals 12 over X squared plus 6, we're going to do that same process that we did and look for all our horizontal asymptotes, x-intercepts, y-intercepts, anything that can help us kind of graph to get an idea of what to do. And again, a graph will be provided for you. So again, I'm going to start with a horizontal asymptote. If the denominator is smaller than the numerator, it's instantly, my bad, I apologize, I said that wrong. If the denominator's exponent is larger than the numerator, we know it's instantly y equals 0. Vertical asymptotes, again, I would try to factor the numerator as well, but it's just 12. So then I take my denominator, which is x squared plus 6, set equal to 0. I get x squared equals -6. Take the square root. Well, I can't take a square root of negative, so there are no vertical asymptotes, right? You do need to check to make sure to see, does it cross the horizontal asymptote? Because it could. So I'll take 12 over x squared plus 6, set equal to 0. Just like we did today as well, we just cross multiply. So that's 12 equals 0, which isn't true. So it doesn't cross the horizontal asymptote. So this is what I know so far. I know I have a horizontal asymptote at y equals 0. I have no vertical asymptotes. I have no slant asymptotes. So I just kind of need to figure out what this graph is doing. So what I'm going to do is, let's see. Let's plug in some numbers. Let's kind of figure out where we're at. So if we plug in 0, that gives us 12 over 6, which is 2. So that will be right here. Knowing that it doesn't cross, that tells me I'm somewhere over here, but I'm thinking it might look like this. But let's do another one. So let's do 1. 1 plus 6 is 7. That's 12 over 7. That's definitely less than 1. So 12 over 7 be basically it'd be a little over 1. And if I plug in 2, that'd be 2 squared, which is 4 plus 6. That's 12 over 10, which is a little bit closer to 1. And then if I did 3, again, that's 9 plus 6, which is 15, which is less than 1. So I can kind of see I'm kind of going closer and closer. I know I won't cross it. So I'm having a good idea that it probably does something like this. But I don't know what it does on the other side. So I'm going to do the same thing. I'll plug -1 in. You know what? If I square the same numbers, I'm going to still get the same result. So that's going to be 12/7, which is like right there. And then if I plug in a -2, that's going to be a positive 4 plus 6. So it'll give me the same result here. So I have a good feeling that these are going to match. So there we go. It doesn't have to be a perfect sketch. I'm just trying to get an idea, like, am I shooting way up or am I coming down? Really and truly, once you got these two values, you saw you're going down, you could have just gone right into it, and I would take that as a sketch. All right. On the next question, it says it gives you a graph and it just wants you to solve the inequalities. So you have, depending that you have the graph in front of you. So if I ask for f of x less than 0, I'm basically just asking when is the y value below the x-axis? And that happens from -infinity to -4, always in parentheses, because well, mainly in this situation, because it doesn't have a less than or equal to. So in this case, it's a parenthesis. So they did add the line or it'd be a bracket. But basically, again, when I'm asking f of x is less than 0, I'm basically saying, look at the graph. When does it fall below the x-axis? And it's from -infinity to -4. Part B says f of x less than or equal to 0. So now this is where it's going to be -infinity to -4 with a bracket, because I want to know when it's also equal to 0. And actually, to kind of piggy on that, since it says equal to 0, if you look, it does cross right or touches the 1. So you would actually say union, little squiggly bracket, and then 1, because it does touch 1. Part C says f of x is greater than 0. So now I'm asking, when is it above the x-axis? So that's from -4 to 1, because technically it's not above the x-axis, it's on the x-axis. and then 1 to infinity. And then part D, I'm asking for when it's f of x is greater than or equal to 0. So this time I can include -4. I can also include 1. So I can just straight up go from here. So that's all it's doing on that one. You just take a graph and then just tell me when it's less than 0, when it's greater than 0, when it's less than or equal to 0, or greater than or equal to 0. All right, these next two, we're just going to solve them like we did today. So that's going to be t minus 3 greater than or equal to 18. Like normal, we would distribute. So this gives us t squared minus 3t greater than or equal to 18. I would subtract the 18 over. Very good. So then when I factor this out, this is a simple one. A trinomial that factors into two binomials where the leading term is going to be whatever the letter is. Find two numbers that multiply to -18 but add to -3. That looks to me like 3 and 6, and then it'd be a -6. So that'd be +3, -6, greater than or equal to 0. I don't got to worry about dividing by a because there's not an a. So my test points here would be t equals -3 and t equals 6. So you would set those equal to 0. So I come over here. Here's -3. Here's 6. Plug a number that's less than -3. If you want, use the most factored form. So -4 plus 3 is, do a different color so I can see my work. So -4 plus 3 is -1, and then -4 is -10. That's going to be +10. +10 is greater than or equal to 0, so that works. Choose a number between, so let's choose 0. So this ends up being 3 times -6, which is -18. -18 not greater than 0. Choose a number past 6, so we choose 7. 7 plus 3. Let me do some new work. All right, so anyways, I'm gonna choose 7, so that's gonna be 10. 1, 10 times 1 is 10, which is greater than, so that one works. So therefore we see it goes from -infinity to -3. Does have the line underneath it, so it'll be bracket, then union, bracket 6 to infinity. All right, if we look at the next one, which is the last one, so this would be -6x to the 4th, 3x minus 4 squared, x plus 2 cubed less than or equal to 0. It looks like I did all the factoring for us. So let's look at our test points. This is a test point of 0. This has a test point of add 4, divide 3. And then this is a test point of -2. So I come over here in this -2, 0, 4, 3. They don't got to be perfectly spaced out. I just like to have this idea so I can put my checks and X's. So I choose a -1. I plug -1 into here. Oh, it's going to be a little bit more tedious. So I plug in -3, not -1, but -3. 3 times 3 is 9. 9 times 9 is 81. So that would be a positive 81. Gives me a negative result. It's really all I'm looking for. So I can just kind of look at all this. 3, so -3, that's -9. It's a negative number. A negative number squared would be a positive. Plug in a -3, that gives me a negative number. A negative number cubed would be negative. So a negative, a positive, and a negative would make a negative. A negative is less than 0, so that one works. Choose -1 this time. So let me, ooh. All right, so now let's choose -1. So -1 to the 4th power is a positive, so this is going to be a negative. -1 would be -3 minus 4. Regardless of what this result is, if it's squared, it's always going to be positive. -1 plus 2 is a positive. Positive cubed is also positive. Negative, positive, positive. That gives me a negative. That actually does work as well. And then we're going to choose between 0 and 4/3. So just choose 1. So if I put 1, it's going to be negative. It's always going to be positive. 1 plus 2 is positive. Cubed is positive. So that's actually going to work as well. Choose something greater than 4/3, like 2. So that actually worked out. All right, if I choose 2, whatever this is going to end up being negative. So that's going to be a positive. That's going to be a negative. So that's a negative result. This is going to be 6 minus 4, which is positive, regardless what the number is. 2 plus 2 is going to be positive. And I see that it actually ends up working out as well. So in this situation, the answer is negative infinity to infinity because it works out every single place. But do make sure you check it. All right, so hopefully this helps. I'll also go ahead and post the paper review as well, just in case you lost it or just want a cleaner copy. See y'all tomorrow.